So today we're going to learn balancing chemical word problems. So we probably have known to balance chemical equations. So now what we're going to do is basically get those equations and put them into this new word problem. So the concept of balancing equations should be the same. It's just we're incorporating how do I say words in English into this rather than numbers and symbols. So before we get into our balancing equations, let's do a little quick recap of our prefixes for these equations. So we have silicon tetrasulfide. So first we want to do is identify the symbol for silicon, which is our first element. So for silicon, it's represented by an Si. And there's only one molecule, one element of silicon, so we just leave silicon Si because the one is understood. Now, for sulfide, first let's identify the element before we get into the number of molecules in this equation, or in this expression. So, for sulfide, it's the element sulfur, and it's just the denotation for "ide." We usually put it at the end when it's in a reaction. So, for sulfur, it would just be a capital S. And notice there's a difference. Silicon is like undercase I. If you put a capitalized I, it'd be silicon iodine, and we don't want that. So just keep in mind about the lowercase. And then sulfur, capital S. Now our tetra indicates it's a prefix for the number 4. So when writing this, we'd have Si is only one molecule of silicon, and then for our sulfur, it would be a 4 because of the tetra. So it would be SiS4 for silicon tetrasulfide. Same thing here with dinitrogen trioxide. So let's first figure out the elements. So nitrogen, we already know it's a capital N. Oxygen, or in what's in an equation, we put ide, so that's how we have this little ide prefix here, so it'd be for oxygen. So oxygen, capital O. Now, di is a prefix for 2, so we have prefix for 2. And tri is the prefix for 3. So when writing this, we have dinitrogen N2 trioxide O3. So just a little quick recap of this. So now we're going to go into step by step again with another written chemical equation. So we have sodium phosphate plus calcium chloride yields calcium phosphate plus sodium chloride. So our sodium has a positive 1 charge, and it's represented by Na. So we can just put a positive 1 here. Our calcium has a positive 2 charge, and it's represented by Ca for calcium. So we put positive 2. Our Cl is a negative 2 charge, or negative 1 charge, and so we represent it by negative 1. And then our PO4, our phosphate, is represented by a negative 3 charge, and we have an O4 here. And it's represented by a negative 3 charge. So now we have our symbols and our charges, we can now piece together the equation as we will in the next slide. So now, piece together the formula. So we're going to write, we have our Na for sodium. Now we have our Na phosphate, or sodium phosphate. So let's see, we have our sodium phosphate, or add the phosphate to it. So let's put our PO4. Okay, so right now we're just going to write out our elements as we normally would. And then what we're going to do is having to put certain number of molecules for each of the elements because of the charges. We have to keep in mind of the charges. So this is a positive 1. Phosphate is a negative 3. Keep that. Plus calcium chloride. So calcium again is a positive 2. And chloride is a negative 1. This yields, we put a little arrow, calcium phosphate. So calcium again, positive 2. our phosphate is -3. -3 plus our sodium chloride. Sodium is a +1 and chloride is a -1 from here. Okay. Now that we have our charges and our elements written out and pieced into this equation, what we could do now is continue to piece together the formula. So we have a -3 here, but a +1 here. So in order to balance this out, we had to have a +3 here for the sodium. So what we're going to put down is Na3. Na3PO4. And then here we have calcium is a +2, but Cl is a -1. So we need to balance it by putting a -2. So this added by calcium chloride with 2 molecules, subscript 2, yields. Here we have a calcium of +2 and a PO4 with a -3 charge. So what we need to do is have 2 of the PO4s, or phosphates, 2 phosphates, and 3 calcium. So we're going to represent it as, in order to balance it out, because opposites attract, trying to piece together, you're doing the math, you're going to have 3 calciums because of the +2 charge, and then, 2. And then for the PO4, we're going to have 2 of those and 3 of the calcium, so PO or phosphate would be represented by a 2 on the outside. And we put the parentheses around the phosphate because there's more than 2 elements and you're trying to make 2 or more molecules in addition to that. So we put the parentheses with our 2 on the outside. And then for the sodium and sodium chloride, since sodium's +1, chloride's a -1, it's understood we could just easily write it as NaCl. So this is our formula written out. This is how it would look. Now what we need to do is balance it. As we notice, I already could see like the Na3, there's 3 here, but there's only 1 here. So in the next slide, we're going to balance our equation. So we need to do kind of the setup for it. So for for sodium, remember it's a +1. So with sodium, if it's a +1 and PO4 phosphate has a -3 charge, we're going to need 3 sodium here. So we would put subscript 3. For calcium, calcium is a +2, but our chloride is a -1. So in order to balance out the +2 here and in order to balance out the +2, we're going to have 2 chlorine molecules here to balance out the +2, -2 charge connection. And and here we have calcium, of course, +2, but our phosphate again, PO4. Our phosphate's a -3 and our calcium's a +2. So what we're going to need to do is, for calcium, we're going to have to put 3 molecules of calcium and 2 molecules of phosphate. So we have the 2 on the outside of the parentheses. And now notice here we don't put the parentheses because we're not adding an additional 2 molecules as we are here. Although we could put it as optional just to put it as a guide. You could put the parentheses if you want. And then our sodium, of course, is a +1. It's a +1, and our chloride, is a -1. So it's just understood as those 2 are opposites attract. Perfect. They're a perfect little perfect right here. So now what we're going to do is we have the number of molecules already set up. So what we have to do now is calculate how many are on one side and balance it with the other. So on the left side of the yield, we have sodium, 3 molecules of sodium, yes. For phosphate, we have only 1 molecule of our phosphate. We have 1 molecule of our calcium. And we have 2 molecules of our chloride. On the other side, for our sodium, we have 1 molecule. For our chloride, we have 1 molecule. For our calcium, we have 3 molecules. And for our phosphate, we have 2 molecules because of this 2 on the outside. So first, let us look at the Ca3PO4 with the 2 molecules. So let's look at the calcium. We have 3 on this side, but only 1 here. So what we could do first is put a 3 here for the calcium. When we distribute this in front, we get our 3 calcium, the calcium is balanced, but this time our chloride is going to become instead of a 2, it's going to become a 6. A 6. Knowing this information, if we have a 6 for chloride, let's focus on the chloride on this side. We're going to need to get 6 chloride as well on this side. So let's put a 6 in front of our sodium chloride. So now that we have our 6 chloride, they both balance, but we have 6 sodium here. And on this side we have 3. So what we could do is put a 2 in front. So when you distribute it, you'd get 6. Matches with this side. The sodium and the chloride are already balanced, and so are the calcium. And when we distribute this 2, we also distribute it to the phosphate. And the phosphate now has 2 molecules. We have 2 molecules of phosphate on this side. So here is an understood 1. We usually don't write the 1, it's understood. This would be the balanced equation for sodium phosphate plus your calcium chloride yields calcium phosphate plus our sodium chloride. This is how the balanced equation would look like. When we distribute it, we have our 6 Na on this, our 6 sodium molecules here, 6 sodium, perfect, check. Phosphate, we end up getting 2 on this side, checks. Our calcium, we have 3 because when we distributed 3 checks. Chloride, we have 6, remember distributed 3, 6 chloride, checks. So the answer, the balanced equation would be 2 Na3PO4 with our 2 molecule and 2 Na3PO4 plus 3ACl2 yields Ca3PO4 with the 2 on the outside plus 6 NaCl would be our balanced equation here. So thank you all for watching this short video on balancing written equations. If you need any help with like balancing equations, you can they're online. There's a lot of like written practices you could do, and if you want to refer back to some of the slides, it's just you need to also have your Know Your Ions PDF if you're in chemistry class, or if you have some PDF file you can use that has the equations written down or the compounds written down for like phosphate or sulfate, you can refer to that. So